Okay, we're solving exercises from a study guide. In this video, we're gonna work with exponential equations. So we're basically gonna solve some exercises related to that. The first one is an easy one. It kind of works to understand how do we solve exponential equations. We need to transform the equation, both of the sides, into powers with the same basis. So the base in here is 3, so we should get the base in here as 3. 81 is the same thing as 3 to the power of 4. If you put 3 to the power of 4 in your calculator, you should get 81. So it's kind of like the same thing. Okay. And once you have the same base on both of them, then kind of like it's kind of like obvious to see that the exponent in here has to be the same exponent on the other one. So you just need to copy the exponents. X equals 4, and that's it. That's all you have to do. Okay, as simple as this. Now obviously things cannot be that simple. Like, we're gonna have to deal with more complicated exercises like this. Okay, I have a 4 in here and I have a 2. I need to have the same base. So to have the same base, I'm gonna change, instead of 4, I'm gonna put inside parentheses, I'm gonna put 2 squared. Okay, because 2 squared is the same as 4. That way I'm gonna get the same base. Now, not only that, when you have an exponent inside square root and another exponent outside square root, you have to multiply them. That's the power rule of exponents. You multiply exponents when you have them inside and outside of a parenthesis. And now that we have the same base, we just need to copy the exponents. So it will be 2x on this side, and on the right side will be minus x plus 3. So I get a linear equation that I can easily solve. The minus x from the right side is going to move to the left side positive, because it was minus, now it's plus. And the plus of the 3 kind of like disappears, it makes invisible. And 2x plus x will be 3x. And that 3 that I have in there, I'm going to pass it to divide to the other side. So instead of 3x, I'm just going to have x, and I'm going to pass that 3 to divide. So I will have x equals 3 divided by 3, and 3 divided by 3 is 1. So that will be the answer for this exercise. And that's it. So let's do another one. Okay. In this case, when you get a fraction, usually that's because you have a negative exponent. Like, you could try, because we're talking about 25, so I know that 25 is kind of like 5 squared. 125 is 5 raised to the power of 3. But because this is a fraction, like this thing is on the denominator, then it wouldn't be raised to 3, but it will be raised to negative 3. It's the same number, only that negative. So that's kind of like what we have to do. We need to make sure to get the same base. So this one, I'm going to change it with 5 squared. And the other one is going to be 5 raised to negative 3. Okay? And now that I have the same base, like, well, I need to multiply as I told you, with the power rule, I need to multiply the exponents that are inside and outside of the parentheses. So I'm going to do that first. And because I have 2 terms in here, I'm going to use distributive property with number 2. With the exponent 2, I'm going to use distributive property. So 2 times 10x, it will be 20x. And 2 times 8, it will be 16. Same thing with this other one. Minus 3 times 4, it will be minus 12. And minus 3 times negative 2, minus a minus is plus, and 3 times 2 is 6, and I copy the x. Now that I have the same base, the base in here is 5 and the base in here is 5, I can copy finally only the exponents. So in this case, on the left side it will be 20x plus 16, and on the right side it will be minus 12 plus 6x. Once I have this is a linear equation, so you just move the x's to the left and the numbers to the right. So this 6x positive, it will pass to the left side as minus 6x, and the positive 16 is going to pass to the right side as a negative 16. So I subtract these things, I will get 20x minus 6x is 14x, and minus 12 minus 16 will be minus 28. So this 14 that is with the x, I'm going to pass it to divide, so it will be minus 28 divided by 14, and that thing will be minus x equals minus 2. That will be the answer for this exponential equation. Now what happens when you have something like this? Like, it looks like the first one that we tried to solve, but the problem in here is that 12, there is no power that's gonna give me 12, and 37 worse, okay? So like, they're not related, so I cannot get the same base as I did with this ones, like 25 and 125. Yes, they have a common base, which is 5, but in this case the numbers are completely different. So when you have a case like this one, what you're gonna have to do is that you're gonna have to use logarithms. So I'm gonna put logarithm of this thingy. Okay, I'm gonna put logarithms on both sides. So if I put the equal, then it will be logarithm of both sides. Logarithm of 37 and logarithm of 12 raised to x. Okay, why do I do this? Because logarithms have a particular rule that tells me that if I have an exponent, I can pass it down to multiply. That way I can transform the x that is as an exponent into a normal number. Okay, right next to the logarithm. So this thing will transform into x logarithm of 12. That is very important because that way I can pass the logarithm 12 to divide. So instead of having this thing, what I'm going to have now is logarithm 37 divided by logarithm 12. That will be the answer, like the exact answer, but like if you're looking for an approximated answer, you can put that division in your calculator. Logarithm 37 divided by logarithm 12. The answer will be 1.4531. Okay, now remember that this is an approximation, so like kind of like a policy, we're not going to use equal but approximated symbol. Obviously on a quiz you're not going to be able to put this symbol, so you're going to put equal, but in a notebook you can do it like this so that you explain that you're rounding the answer. And that's it. That's how we work with exponential equations.